Differentiation and integration can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular functions. As an example, cost, strength, amount of material used in a building, profit, loss, and etc. The applications of differentiations covers 5 subtopics, which are related rates, analysis of function 1, analysis of function 2, applied maximum and minimum problems, and rows and mean value theorems. For our group, we are going to be covering the topic related rates and applied maximum and minimum problems.
Assalamualaikum everyone. Today I will share with you how to solve a problem about related rate question. Okay, let's look at the question given. For this question, a conical water tank filled with water has a radius of r cm at the top and h cm height. Okay, at the question A, if the height of the water is twice the radius, show that V or volume is equal to 2/3 pi r cube. For the question A, firstly, we must find the formula for the cone volume because it's a conical water tank. Okay, formula for the cone volume is 1/3 pi r square h. Okay, from the same question, we also can get another information, which is height of the water is twice the radius. Okay, we write this information here, which is h is equal to 2r. Okay, for settle this question, we just replace h with 2r. Okay, for the original formula for the cone volume, we replace h with 2r. Okay, and after that we will get the answer, which is volume is equal to 2/3 pi r cube, which is the same as the question 1. Okay, that's all for question A. Okay, let's move to the question B. At the question B, water flow in the tank at a rate of 15 cm3 per second. How fast is the radius changing when the radius is 4 cm? For this question, we must find the information that we can get from this question. The first information that we can get is water flow in the tank at a rate of 15 cm3 per second. It means dV over dt is equal to 15 cm3 per second. So we write this information here. Okay, how fast is the radius changing when the radius is 4 cm? So we know that this question, one way to find a value for dr over dt when the radius is equal to 4 cm. So we write here. Okay, to find the r over dt, we must build a equation. To build an equation easily, we put 1 dr here and 1 dt here. Refer to the information that you already have. You have a value for dv over dt. So we put 1 dv here and 1 dv here. Okay, dv over dt is equal to 15. Okay, but we don't have a value for dr over dv, so we must find a value for dr over dv. Okay, to find a value for dr over dv, we must use a volume. Okay, volume is equal to 2/3 pi r cube. Okay, we get the value from the equation here. Okay, when we differentiate v, we will get dv over dr is equal to 2 pi r square. Okay, to turn dv over dr to dr over dv, we just put 1 up here, and we will get 1 over 2 pi r square. Okay. The next step is we write again the equation. Okay. And we insert the value that we already get. Okay. But again, dr over dt is equal to the value for dr over dv is equal to 1 over 2 pi r square, and we insert here and multiply by dv over dt value, which is 15, and the value for dr over dt that we get is 15 over 2 pi r square. Okay, after that we replace r with 4. Okay, so we insert 4 here, and the final answer that we get is 15 over 32 pi. Okay, don't forget to insert a unit. Okay, we know that radius multiplied with was time, and the unit for radius is cm and time is second s. Okay, the final answer that we get is 15 over 32 pi centimeter per second. Okay, done for question B.
Okay, Assalamualaikum everyone. Okay, today I will share to you about how to solve applied maximum and minimum problems. Okay, first we will take a look for the question. Okay. A closed cylindrical container of radius r cm and height h cm to be made to hold 600 cm3 of the liquid. Okay, the question is, show that the surface area of the container is 2 pi r square plus 1200 over r. So we need to show the surface area of the container. Firstly, we can draw an image of the diagram. Okay, so we can imagine how this look like. Okay, and then we written here v equals to 600 because we already given here 600 cm3, which is the volume. So for the area, we need to find what is the formula of the surface area of the container. So the surface area is A equals to 2 pi r square, because we have 2 circle, and plus with 2 pi r times h. So this is for this one, and this one is for this one. Okay, and we need to find the volume, which is pi r square h, which is the volume of the cylinder. Pi r square h equals to 600. So we need to exclude h, because in this equation it does not have h. So we need to change h equals to 600 over pi r square, and then we include in this equation. So 2 pi r square plus 2 pi r, h is 600 pi r square. So 600 pi r square, and then equals to 2 pi r square plus 1200 over r, which is this one. So we already show that this equation is equals to this one. Okay, then for question 1. Okay, for question 2, we need to find the value of r and h that minimize the total surface area of the container. So for step 1, A equals to 2 pi r square plus 1200 over r, which is the equation that are given. To make it easier to differentiate, we need to change this equation to 2 pi r square plus 1200 r power of -1. So for step 2, we need to differentiate this equation. So dA over dr equals to 4 pi r minus 1200 r power of negative 2. So for step 3, we need to dA over dr equals to 0. So 4 pi r minus 1200 over r square is equals to 0. So from this equation, we can find the value of r. So 1200 over r square equals to 4 pi r, and 1200 is equals to 4 pi r cube. 4 pi r cube is equal to 1200, and r cube is equal to 1200 over 4 pi. So r is equals to cube root 1200 over 4 pi, and r is equals to 4.57 cm. So from the value of r, we can find the value of h. So the value of h is equal to h equals to 600 over pi r squared, and 600 is over pi bracket 4.57 cube, and h is equals to 9.14 cm. 9.4 cm. Yeah. Okay, 9.4 cm. And then you will define r and h. So for step 4, d square over a, d square a over dr square is equal to 4 pi plus 2400 r power of negative 3, which is the definition of this one. Okay, and is equal to 4 pi plus 2400 over r square, r cube, sorry, and 4 pi plus 2400 is over with 4.57 cube, is equals to 37.71, which is bigger than 0. So if the value is bigger than 0, the area is minimized. Therefore, the conclusion, r is equal to 4.57 cm, h equals to 9.14 cm. We minimize the area. So done for question 2.
After finish solving the question's problem, we can conclude that the application of differentiation is used to compute the rate of change and find minimum and maximum regarding the questions. We use related rates to solve our question's problem because there is rate at which one quantity is changing and relating it to other quantities whose rates are known. We also apply maximum and minimum problems to determine the maximum and minimum values.